Today we're mostly going to focus about working with standard data files. But before we start speaking about the different formats, I want to say a few words about where we get these files from. So each website has its own interface for getting files to download data. And of course, it's very site-specific. But one particular interface that I want to linger on is called an FTP protocol, which stands for File Transfer Protocol. I think it might be the best to begin maybe with a quick example so you can see what exactly it is. So let's, as an example, go to the UCSC website, which I won't say much about now because Michal is going to show it to you soon, the UCSC browser. But let's see how we can download data from UCSC. So I Google search UCSC and I get the first result, UCSC Genome Browser Home. And then I can go to Downloads and select the FTP option, which you see here. So this is quite a standard protocol, and you will see that many websites support FTP. And this is quite convenient because it provides you some kind of, you can think about it as some kind of remote directory that you can access and take subdirectories or file from into your local directory system. So you can see here that it has a link. You see the download page at, no, not this one, sorry. Yeah, here. You see, instead of HTTP, it begins with FTP, meaning it's a different protocol. This is the FTP protocol. But like HTTP, it is supported by browsers, so you can view it. It shows a little bit differently in each browser, but you will get the gist of it. And here we may want the golden path. Let's zoom in so you can see. And you can see this is like a directory. I can select any directory and just navigate within it. So here, what I want, let's go to version AG38 of the reference genome. And let's select, what is it? It should have chromosomes. Okay, and you see that within this inner directory, I get all kinds of files which I can select. Okay, so this is a way to download actually the reference genome from UCSC. So each of these is just the actual reference genome, the actual nucleotides of the reference genome of version 38 of the human genome, and each one for a different chromosome. So for example, I can download, let's take a small one, maybe chromosome Y. So you can see this one is only 8 megabytes. I can click on it and can save the file. And that's basically it. Okay, and then I got this file into my local computer and I can start working with it. Okay, so this is, I think the most straightforward to access FTP is through the browser. But there are other options. You can work with command line interface, which is often supported. I think in Linux it's pre-installed. In Windows you can install it if you want. There are also special softwares that work with FTP. This is mostly useful if you work with larger files, which if you download it through the browser, it can take too long and it will probably cause you some error along the way. So if you work with big files, it might be a better option. And yeah, that's basically it. Okay, so now let's talk about the main theme of today. So in the previous lesson, you started working with files. And in the examples that you saw, these weren't any standard kind of formats. This was just some very specific format that we made up, and you had to parse it. And you probably saw that it wasn't so much fun to parse files. So yeah, parsing is very often something we have to do because all kinds of websites make their own formats, and we cannot keep track of everything. But very often, people do use standard formats like the ones you see here, JSON, XML, CSV. And if they do use a standard format, then it's good news for you because you do not have to write your own homebrewed parser. You can just use some built-in package that will do most of the parsing for you. So let's start going over different formats that are very, very, very common. So the first one is the JSON format. Which of you, by the way, have ever worked with JSON? Okay, so some of you. It's quite a common format. The nice thing about this format, along with the other two I'm going to show today, is that it's very readable. So it's just basically text. So meaning that it's readable both for you as humans and for the computer, which has its parser. And it's very nice that you can actually look at the data. It's not some binary that you do not have access to. You can actually see what's going on. So maybe let's start again with a quick example to illustrate what JSON looks like. So in the Moodle, you will find a file which I already downloaded. It's called the hypervirus genome.json. You can open it. I will open it here now with Notepad++. Okay, so you can see basically it's just text, a very long line of text. Maybe I will break the lines so we can see how long it is. Okay, so you can see it's a pretty long line of text, but I said it's readable. It is readable. It's text, but it's not very easy to navigate this complex data structure just by looking at the long line. If you want to get a better look at what it actually looks like, you can use some formatters. There are online tools which you can use that will take this raw string and will display it in a more pretty way that you can actually look. So if you just go online, you search on Google and something like, I don't know, online JSON viewers, say. I'll just take the first option. And yeah, it basically lets you put some JSON string here. So I just copy paste it. And then format, I suppose. And yeah, and you can see that it looks much nicer. And now you can actually see the hierarchy of this data structure. So you can see that it actually looks very, very similar to Python. So it's almost Python in a way. You can see that it's actually a big dictionary that has keys and values, where the keys are strings and the values take all kinds of types. And you can see that the coding regions, for example, it maps to a list which contains yet more dictionaries. Okay, so each one of these is a dictionary within this list, within this dictionary. And you can see that this inner dictionary, again, it has some keys and some values, and the values again can be lists and dictionaries. So it's a very nested format, which is made up of basically lists and dictionaries and native types. And it can be as deep as you want it to be. And again, very, very, very similar to Python. You can almost see no difference, except for maybe you can see that the Boolean values are with lowercase, whereas in Python it's capitalized. So there are very, very small differences, but it's almost like Python. And the file that I show you here is an example of just, we downloaded it from the RefSec, I think, or you can see some metadata about the genome of this specific virus. So you can see it has a chromosome with some name, and it has 77 different proteins. It has a specific GC content, and then you can get all the coding regions. So each one of those is a different genes, which we can see the protein name and the protein sequence and the protein ID and where it is located on the viral chromosome, and so on. Okay, so it contains very complex and rich data in a very structured and neat way. Yeah, so like we said, it supports all the kind of native types. It supports integers, floats, Boolean, string, and null. Null is the corresponding in JSON to the none in Python, and of course lists and dictionaries. And it's very, very convenient to use with dynamic languages like Python. So when I say dynamic language, I mean a language where you do not have to predefine the type of every variable, like for example, say Java or C. In those languages which are not dynamic, it's much more complicated to work with JSON because you need to pre-specify the type of everything. And when you work with something like a dictionary within a list, within a dictionary, within a list, it's not very easy to specify the type, so you need all kinds of special types for those languages. But in Python, it's very easy because they just give you whatever it is, and you don't need to know in advance what type it will be. Any questions about JSON? I will show you later code examples of working with JSON, but about the format itself, any questions? Okay. So let's move on to another data structure. Actually, about XML, I'm not going to say too much. I'm not going to show you code examples dealing with XML because it's, although it is a common format, it's not as common as JSON and CSV, which I will soon show you. But it was, especially in the past, it was very popular. It actually precedes JSON. But over time, JSON is becoming increasingly popular, and XML is somewhat falling out of favor. Again, you can see here on the right side some example of what it looks like. Like JSON, it's a very hierarchical structure. But it's somewhat more complex. You can see, for example, here we have some data structure of books. So you have, this is called an element. This element of books has some sub-elements. Each of them is called a singular book. And you can see that it has some attributes, like you see here. Some ID maybe, and then some other sub-attributes, the title and the author of each book. And in some sense, it's even more readable than JSON. It's very nice, but it's also somewhat harder to work with within programming languages because there is no clear mapping into Python objects like we had with JSON. So here you have some more complex entities, these elements which have both attributes and sub-elements. So if you want to work with XML parsers, it will come with some new custom data types. And for that reason, it's somewhat more complex, and people prefer most of the time to work with JSON. But it does have some advantages. So it is slightly more readable, like I said, and it's also more scalable than JSON. So if you work with very, very, very big data structures, most chances it will be in XML and not JSON. Because JSON loads everything to memory at once most of the time, whereas with XML you have many parsers that can work, that can actually process the data dynamically online. So you can just read some data to process it and then read some more data and so on and so forth. So again, I'm not going to show how to work with it here, but if you happen to use an XML and you need a parser, I do recommend you to use the LXML. Which is a very good Python library. It's both very efficient in terms of memory and CPU, and it also has a very nice interface. So check it out if the need ever arises for you. And finally, there is CSV. Again, let's begin just with a quick example. So again, you can find in the Moodle, it's called ViperDB CSV. So let's actually start with opening it as text. So the ViperDB is some database, again, of viruses. This is a database that contains structural data about viruses. So it's actually derived from the PDB, the Protein Data Bank, which gives you some X-ray and images of 3D models of proteins. So the ViperDB uses this data to analyze mostly the capsids, the outer protein layer of viruses, and gives you some kind of physical measurements. So let's see in this example what this data type looks like. So the first row that we have is actually the titles, the headers of this database, and then each line is a different row. And you can think about it like some kind of a big table. So the kind of headers that we have is some entry ID, family, genus, some taxonomy of the virus, then title, and all kind of physical measurements of viruses. Now, the thing about CSV format is, like the name suggests, it's called the comma-separated values. So it's just a bunch of values of strings separated, in this case, by a comma. Okay, so each line you can see that it's actually separated, and you can see all the values. And the convention is that each line should contain the same number of values. So it is translated to some kind of tabular data. Now, it's not strictly mandated by the format. So you could, in principle, have a CSV file where each line has a different number of values. But people typically won't do that because they want it to represent some kind of table. And in fact, it's so common that it's supported by the Excel program. So if you just take a CSV file and you double-click it, then by default, it will open with Excel, which here shows it from right to left for no good reason. Layout. Yeah. Yeah. Okay. So you can see it opens as a in Excel, and then you can work with it like you work with any Excel file. But you do need to be careful if you want to open CSV files with Excel, because the Excel program, while it's very nice, it does take sometimes too much liberty to mess with your data. They try to make all kind of automatic inference of types and stuff like that. So for example, it's very common that it tries to convert all kinds of values into dates sometimes, if it sees something that looks like a date. Sometimes it converts things to numbers for no good reason. I think I have an example here. Here you can see here, one of the IDs was interpreted in Excel as some kind of a very large number, where it's not actually the right value. Now, I think that if I save it as a new file, it will even keep this change. So it's very dangerous to work with Excel. There was even some report, I think it was in Science or Nature or something like that. They argued that like 25% of published papers contain some kind of a mistake or a bug because of using the Excel program when doing the research. So I think it's much safer to make your own analysis in Python. If you work with the CSV parser in Python, it won't make all those kinds of manipulations to your data without your consent. But sometimes, especially if you want just to look at the data, it's very convenient to use the Excel program. Okay, so like we said, it's just comma-separated values. But it could, in principle, be any kind of delimiter. So for example, it's very common to use tabs. Sometimes it even has a distinct name. Sometimes people call it TSV, tab-separated values, although it's still CSV, just with a different delimiter. So you will very often see that you have values separated by tabs, and you can use basically the exact same libraries that you'd use for a standard CSV, and you can use any other delimiter. People sometimes use a semicolon. So it depends on the data. And yeah, it's very readable, very easy to read and write. And we're going to see an example of that. Any question before we see some code examples? OK. So let's see code examples. So I took the JSON and CSV notebook. Can everybody see? OK. Yeah.
How do you edit the JSON markdown that you have there?
Yeah, it's a title, so it begins with this hash symbol. So everything you put within a hash will be a title, and you can also add subtitles. Yeah. That's what we were asking?
Never mind, something else.
You need to change the cell type.
Yeah, no, that it's a markdown, that one is code. So if I change it to markdown, it will no longer be interpreted as Python. And whereas if I change that to code, it will think it's just a comment. Okay, so let's begin with JSON. So I basically take the same file which I showed you. I put it in the C downloads directory. And now if I want to open it, I just basically open it like any other file. I give the file path to the open function, and I give it a reading mode. And now instead of using the fread function like I used when I wanted just to read the raw text, instead I will import the JSON package. I will use the JSON load function on this file handler which I created. And then its output I will store into a data variable. Of course, I will make sure to close the file. And now I have everything that JSON parsed within this data variable. And you can see that when I print its type, it's actually a dictionary, just a plain old Python dict, not any special value. Okay, and it makes sense because when I showed you this file in the viewer, you saw that it's actually a dictionary in the uppermost layer. So JSON will basically give me whatever it is in the uppermost layer of this object. So if it's a dictionary, it will give me a dict. If it's in a list, it will give me a list. If it's a number, just one number, it will give me an integer, maybe. Now, it's not such a big dictionary. I could, if I wanted, just to print it. But here I wanted to give you some more general guidance of how to work with data types that you have just parsed, but you're not quite sure what they contain. So in general, it's not a good idea when you parse some JSON just to print it to the screen, because it could in principle be a very large object. So if you take a few megabytes file and you parse it as JSON, I would not recommend you to print it to the screen. If it's a few dozens of megabytes or even hundreds of megabytes, it can be a real disaster to your environment. It will probably crash your Jupyter and you will have to restart everything. So rather than doing that, what I do recommend you to do is very cautiously to try to navigate and see what this data type looks like. So let's maybe begin with checking what's the length of this data, how many objects it contains. Okay, so in this case, it's only 7. So it doesn't look that much. But again, it doesn't mean that I can just print it, because even a very, even a dictionary with just 7 elements could still be a very deep data structure. So maybe one of those elements is itself a list with 2 million objects. So it still won't be a good idea just to print it to the screen. Instead, what I can do, I can start navigating through this dictionary and start to see what the keys and values are. So about the keys, I do not have to worry, because people don't use very large objects as keys. But for values, it is safer not to print the values because they could be very large. Instead, in this case, I just want to see what type they are. And you can see that I have a name, which is a string, and I have a protein number, which is an integer, a GC, which is float, etc., etc. So everything except of the coding regions is just native type. So with native types, I do not have to worry, because again, typically people won't use very long strings, and they definitely won't use long integers or long floats. So everything other than the coding regions, I can just safely print it and see what the values are. And I can actually see the key and the value of all the things that is not the coding regions. Now with the coding regions, I do need to be more careful, because again, it's a list. So I do just the same thing I did with the dictionary at the beginning. Okay, so I do it recursively. I take these coding regions and save it into a variable. And now I can check its type and see its length. And again, see it's a list with 77 elements. And I repeat the same process that I did at the beginning. So just to get a sample of what it might look like, I take the first of these elements in the list. And I see that it's a dictionary. So I will check what's the length of this dictionary, just 4 items. And I will see the key and the type of the values of these sub-elements. And I see that everything other than intervals is just a string, so I can just print them. And I can see that it has a product name and amino acid sequence and the protein ID. Now again, the intervals are a list, so I need to be a little bit more careful with them. I see just one element, so I take it. Notice comma, by the way, so I'm not taking the list, I'm taking what is within this list, okay? This is important. And I see that it's a dictionary. And again, I repeat the same process. I see that it has 3 elements. All of them are natives, so I don't need to worry about it. So I can just print the entire dictionary because I see everything with it is just native types. I can see that it's not a very large dictionary, it just contains 3 elements, the start and the end coordinates within the chromosome, and whether or not it's on the complement strand. And now I saw that actually the coding region is not such a horrible dictionary. It contains just a few native types and then this dictionary, which is not too big, so I can just print everything. I see that it's not too big, and I can see the entire structure of each of these coding regions, which represents one gene, one protein coding gene on the viral genome. So I can see everything, all the data structure. And that's basically it. So now I understand what this data structure looks like. So to go back to the beginning, I see that I have some dictionary with all kinds of fields. And then I have the coding regions, which is a list of dictionaries where the structure of each of these dictionaries I have figured out here. Okay, so that's the way I actually recommend you to approach this kind of task of navigating some unknown data structure. Do it carefully and just repeatedly see what you find inside. Any questions? Okay, so I think maybe we'll stop here.